Catalogue Permutations V1.0 with June Lee, which is looking at Grasshopper and some Blender. So I'll introduce June, who is a New York-based architectural designer and artist. His works involve not only conceptual spaces with parametric geometry, but also a series of various abstract designs and artworks. He has a keen understanding of abstract concepts and creates complex forms using simple processes and design languages. Lee focuses on integrating organic flow, repetition, random generation, continuity, and overlap in his works. He explores architectural elements on different scales by applying the same design concept, and these correlated works serve as the most important source of future inspiration. So, welcome, June. We're happy to have you.
Thank you.
For everyone here, just some notes about the webinar. If you see in the chat, June has posted a link which has files for you. Just want to remind you that this webinar is recorded and you will get an email for the recording after the webinar within a day. And that's just keep in mind that not everyone learns at the same pace, and we want to give you as much content as possible. So if you feel like the live webinar is too fast, just sit back and watch, and you can always go back to the recording. But if you do have questions, please do write them in the chat or in the Q&A button. Yeah, so hand it over to you.
Yeah.
Using this website.
Sorry. Can you see my keynote?
Yep.
Okay. Okay. Hello. Thank you for joining this.
Right now we see a timer. Is that correct?
Oh, sorry. Should be fine.
Now we see the keynote.
Yeah.
Yes.
Okay. Hello, and thank you for joining this class today. I'm Jun Lee, and I'm really excited to share with you some of the techniques and strategies I use in my design process. Today, we are going to dive into how I use Grasshopper and Blender 3D to create parametric designs. These are powerful tools that, when used together, can really enhance your ability to create complex and dynamic designs. Whether you're a beginner or have some experience, I hope to provide you with insight that will help you take your skills to the next level. Over the past few years, I've had the opportunity to work on a wide variety of projects, and Grasshopper has been a crucial part of the journey. One of the key reasons I rely on Grasshopper is its consistency. Once I've developed a script, I can be confident that I will get the same design output every time I run it. This consistency is particularly important when you are working on a large project, where even small variations can lead to significant discrepancies in the final product. To elaborate, when you follow a Rhino tutorial to model something, even if you replicate the steps perfectly, there still can be differences in the final outcome. These variations might be due to your individual design sense or slight differences in dimensions or proportions. So Grasshopper, however, removes that. Sorry. removes that uncertainty by ensuring that if the script remains the same, the output will also remain consistent. So this reliability is invaluable, especially in collaborative environments where multiple people might be working on the same project. Collaboration is another area where Grasshopper excels. Its visual programming interface makes it easier to modify and understand the design logic. When working with others, it's much simpler to share a Grasshopper file and discuss the design process because everything is laid out visually on the canvas. This clarity not only facilitates collaboration, but also makes it easier to revisit and refine designs at a later stage. Moreover, the reusability of Grasshopper script is something I greatly appreciate. Over time, I've built up a library of scripts that I can return to whenever I need to do. This ability to reuse and adapt previous work saves a tremendous amount of time and effort. Rhinoceros, while powerful, can be more challenging to decipher, especially when dealing with large and complex models. In contrast, Grasshopper script is more intuitive to navigate because every step of the design process is presented by a node on the canvas. For me, these reasons, consistency and reusability, have been particularly helpful in accelerating my design process. By saving and organizing scripts from previous projects, I've been able to develop a personal design languages and that I can draw upon in future work. This growing library of scripts and designs continually inspires me to push the boundaries of what I can create. So I understand that starting a new project can be daunting. This page is always so scary to me. The blank canvas can feel overwhelming, and it's easy to get stuck wondering where to begin. That's why I often start with simple scripts or by revisiting designs from previous projects. These serve as a foundation that I can build upon and adapt to the specific requirements of the new projects. So here are a few examples how I've repurposed earlier designs to develop architectural concepts. Some of Voronoi or boxer or a pipe and void and folding and rotation. And it is also important to remember that it's perfectly fine to use multiple images or scripts in a single design. In fact, combining elements from different projects can lead to innovative and unexpected results. So by categorizing and organizing your designs, you can experiment with how different elements can interact and come together to form something new. Like here, extrusion and opening, Voronoi and catenary and bezier curve and random population. And don't worry about reusing the same scripts multiple times. Each time you incorporate a script into a new project, you have the opportunity to tweak and refine it. Even small changes can lead to significantly different outcomes, so the results will never be exactly the same. For example, I've used the same script in many projects, but each time it has produced dynamic and unique results. This iterative process not only helps refine your designs, but also allows you to discover your own design preferences and develop distinctive design languages. So now let's dive into some of the scripts I've created and see how they can be combined to produce complex and engaging designs. I'll also be sharing some tips and tricks along the way that I found useful in my own work. So let's get started. So here you can see the number on top right corner, and that is the number is associated with the Grasshopper files you downloaded from my Google Drive. So you can see the 01, 2, 3, and 4. And 01-A is for the point-based design at the top left here. Then B is for the line-based design, C is for the surface-based design, and D is for the pattern, E is for the utility. So I will explain these first and show you how to combine these ones. So like 02-1 means B1 plus D1 or B1 plus D2, something like that. And then 0-2-2 means this 5 script is combined in one design. 0-3 is also 5 script is in the one design. And 0-3 and 2. So I'm going to start really simple things first and then moving to more complex one. And then after go over all these scripts from Grasshopper, and I'll show some Blender 3D work and also for the how to make a simple material in Blender and the way how I rendered with a cycle render. Okay. So if you downloaded the Grasshopper file, let's open the 0-1 point-based design. Okay, so I'm going to explain the A1, the populate point. So this point-based design is not the preferable way for most of time because this is really good to explore some unexpected design, but it also has to, you should rely on the very randomness, and sometimes it has a problem with the connection part of its surface. But I still want to show it's worthwhile to know what I did before. So let's start with the first design. So it's a Grasshopper, and everyone knows just double click to have a new component, something like that. I made a center box here for the populate 3D. So I want to populate the 10 points in this center box. By the way, what I'm doing is just click the here, and you will have a palette, and you will have a enable the component and disable component, and turn on the preview and turn off the preview, because I don't want you to spend all the time to borrow my process on your own now. I just gave the first script, so I just what I'm doing is to enable one by one gradually to show the process. Okay, and now I want to use this point as a center of the spheres. So now you have some number of spheres with the different radius. Here, you can change the seed number, something like that. You see the design is so random. That's why I don't use it too much, but here it has very great potential to find something new. So in this case, I just like this one, the seed number 1. And then here, you set the range of the minimum of the radius and maximum radius. So 30 is the minimum and 90 is the maximum radius. Okay. And then now I'm going to cut these surfaces. So it's something like looks more like a building to land it in the ground. To do that, I use the solid union. Solid union is the same as something like a Boolean union in a Rhino space. So now it looks is combined well. And then I make a circle to use a cutter to cut this BREP. And then literally we can use the split BREP here. So this circle is a cutter and the target BREP is what we made here. And then here, now we have a surface, but we cut it. In this case, we just have two BREP. One is upper than the ground line and one is below the ground line. So if you have a lower one, sometimes it happens, just change it to 0 and 1. So just change it until you get the correct result. In this case, this is 1, so I kept this. Actually, this BREP we don't need. You can just directly connect. What for now is I just put it for the reference. And then I'm using a populate geometry again on this surface that we have, and have a Voronoi 3D here. So now we have some subdivision on our surfaces. If you change the number, we have more subdivision like here. But now I think 100 is enough for this design. Okay. And now I'm using a solid intersection, which is same as a Boolean intersection in Rhino space. And now we divided our sphere surfaces by the Voronoi pattern. So now it's subdivided by the Voronoi. Okay, looks good. And now I'm going to make a hole inside of the sphere, so it's something like a space inside the building. So I'm going back to here, what we have in the random points. So I'm making another sphere. So it's the same radius, so it's completely same, but I'm scaled down here. So to do that, when we have this area component, we use it when we need to get the center of the surface, but it's normally used for the 2D. But this case, it just works. But normally, when you do the 3D, we use the volume component and use center here. Okay. Nice. Okay. Okay. Now there is the scale down spheres. You can just change the scale here. This time I'll use 70%. Okay. Now I'm going to use solid difference, which is same as a Boolean difference, to make a hole inside. So this from the big surface and minus the smaller one. Okay. And then you see now we have a hole inside the building. It looks good. And then this looks a little bit simple. So I'm going to use random radius. I don't know why there's no name. This is random radius, which is really good to have some variation. So now we have 104 surfaces here. So I want to reduce 50 surfaces. And then result is something like that. Looks much better. You can change the number of the surfaces you want to delete. But in this case, when you change this number, the subdivision of the Voronoi will be changed. Now it's 100, but sometimes you can increase, crazy number, is 300, 500, something like that. And then this number should be changed and you have to do that manually. But instead to do that, you can just use list length. And then now you get the number of lists. So you have, in this case, you have 104 surfaces. So connect to the multiplication. And then just put the number from 0 to 1. So you can select the surfaces in the proportionally. So now you have the full surface and reduce 10%, 20%, 30%, 50%, something like that. So you don't need to worry about the number and don't need to manage every time you change the number. Okay, now I'm going to make some very simple structure with the pipe component. To do that, I'm going to use deconstruction BRAP. Deconstruct BRAP enables you to extract all the faces and edges and vertices. And then normally, what you can do is just directly connect edge to the curve. But in this case, what I'm going to show is because these surfaces from the multiple spheres, there is a strange seam here. You see the green line. Here, something like that. It's very light, so I'm not sure you can see, but still there is. That's why I put the BRAP edges. I just want a naked curve to have a clear structure. I just don't need the interior one. That's why I put this one. But normally, in most of cases, if you want to have some structure, just you can simply put this edge nose to the curves. And then you don't need. And then pipe. Okay, now you have the simplest pattern pipe structure here. Okay, looks great. And if you have all the structure, you can just simply right click and then click bake. It's good to check the making group. Okay, now you have the model in the Rhino space. Then I also want to bake this one for the surface. Yes, group. Okay, then if you click here, you can only see when you select the component. So just check in the Rhino space, just click the Rhino space, tap the Rhino menu, and then go to view and go to rendered. Okay. Okay, now it's already done. So it looks great. So yeah, when you try to make some model with the center points and use the primitive surfaces, maybe it's great to start point. But I'm going to show the more preferable way, which is starting from the curve and the surface. But just, yeah, it's good to know. So, okay, Now let's go for the line-based design. So I'm going to show how I made curves for the starting point of the design. So let's open the 01-B line-based design. Okay. Now I'm going to show the V1 Bezier curve first. Okay. So now start with this curve. Okay, this is the construction point. This literally, if you want to make a point, you can just put like that and set all the X, Y, Z coordinate. If you don't put anything here, it's just 0, 0, 0. So it's the starting point here, this green point. And then I'm making another construction point, which is 200 away from the center point in x-axis, and then z-axis I also moved up in 50. So you can just adjust easily. And then I use the Bezier span component. It's really easy way to have a great curve. And because this curve is along the x-axis, I put the unit x in the start tangent and end tangent. So you see, if I'm going to 0, it's just a linear curve. But when you start to increasing the value, now it looks great, gradually starting and gradually stop here. So for most of design, I think this is much better than just a linear. So yeah, this is very simple and easy way to have a great curve for the starting point. And then it's the same, I just copy it here. And then you can change or the coordinate again and the same. But like I just, it's too much with the 100 vector. So I'm using the 50. Okay, this is the one way I can have a Bezier curve, but there is another way we can make Bezier. So let's check that out. Okay. There is a component line XDR, which I can set the starting point of the line, which is the center point, 0, 0, 0. And then I use the unit x for because I want a line along the x-axis. And then you can set the length here. So now I'm set 200. And then I'm going to divide this curve in 50 counts. So now you have all the points along this curve. And then as we did previous script, I used the list length to gather all the numbers. And then I'm going to divide all this value and we map all the values following this Bezier curve. So what I'm going to do is now you divide it into 50. So we have 51 points here. And also this is a 51. But in here, so definitely we need the 51 z values for z coordinate. But if you put just like here, you will have a 52 values, so it doesn't work. So that's why I put the -1. So minus 50 step means 51 z coordinates here. Okay, so I'm going to use the remap numbers and graph mapper. So I set the minimum number of z coordinate and the maximum number of z coordinate. Okay, if you see like that, so this is the result. So this is the minimum is 1. If you put this point down to ground, you can just set it 0. So now it starts from the ground. And then you can set the maximum number, something like that, or something you can easily change. And just right click the graph mapper. You can do any kind of graph form. This is iconic or Gaussian, something like that. So you can easily have any kind of curve with the graph mapper, thing in parabola, something like that. I'll go with the Bezier. So you can change the tangent by using this curve. Okay, and then when you have the set of points, you can use interpolate component. So now you have a continuous curve here. Okay, looks good. And then I'm going to show the mirrored Bezier curve. Sometimes this curve looks great, but sometimes in architecturally, if it's going up, it should go down again. So, but in this case, if I use parabola, and if you something like that, this tangent is too big, so I don't think it's gradually going up from the ground and going down to the ground. That's why I have this script for the mirrored Bezier curve. So let's start with this one. I already internalized for one curve here. If you want your own curve, just have a curve, something like that. And then select the curve and right click and set one curve. Or if you have a multiple curves, just select everything and set multiple curves. So you can use your curve or you can also set the points the same way. Okay. And now the same way, the divided curve. And then I'm going to use the series component. And I choose some of the points in the middle of the curves and then moving up by using graph mapper, Bezier, following the Bezier curve. And then mirror it to going down gradually and then replace that point by using this replace items. So let's start from the one by one. So now we have 31 points, and I want to choose the points in the order of the 7. And then I want a number only for the integer, so I put the number 1 for the step. And then count. I have this one because I want an even number, so I multiply 2 and then plus 1. So this way, I always get the even number in the count. And then this number, I connected the steps. So now I have 11 vectors, 11 data here, which is going to follow this Bezier curve. So now you see the 11 from 0 to 1 is divided, and then this going to the D1. And then I reverse the list and then put it in D2. So what happened here? So I select the 10, 11 points. So from A to K, so it's going up gradually by following this graph mapper in a Bezier curve. So it has a z coordinate now, and then reverse this list, so it's going down again. But when you mirror the data, there is a 1 in a axis, in which is the K. So I want to remove K in the list. So I use the curve index, which is 0. So I put out the K by using this curve index. And then I merge all this data in the one. So from A to K is in D1 in a merged component. And then from J to A is connected to D2. Okay. And then as you see here, sorry. Now here, from 0 to 1 and 1 to 0. But this is too small for the z coordinate, so I put the multiplication, make it higher. So like here, this is the result. You can change the number in the multiplication, so have some more openings here. And then I'm going to replace original points to this one, which is moved up in z-axis. So I use the replace item component and put it in the item. And then now you have only these points, not the original one. Okay. And then the same way, use the interpolate component to have a curve. So now, yeah, you have the mirrored curve, mirrored Bezier curve here. Okay, let's hide. And let's go quickly with the sine curve. This is the really simple way. See the steps is the number of points. So if it's too small, sometimes the result is not good. So make sure you have a high enough number to make some natural sine curve here. And then here, this is the cycle of this sine curve. So start with just 1 and 2. This is 360 degrees, so more and more, something like that. Good. And because this curve is along the y-axis, you can change here. You cannot just length up in y-axis. Also, you can put the sine component and change this number for the z coordinate for the sine curve. Okay, and always same, use the interpolate. In here, this curve is only on the YZ plane, so X is just nothing here. Okay. And then this is the same way, same script with here. We did in Bezier curve, second Bezier curve. You can just right click in the graph type and then go to sine. Then, yeah, it's very easy way to have a sine curve. See, this is very strange. In that case, just have a high enough number for the division, and then you will have a correct sine curve here. Okay, this is some ways to I make the curves, and then let's go to the third one, the surface, how to make the surface. Okay. And now open the 01-C surface-based design. Okay. Okay, here, this surface looks already quite interesting. As I just wrote what we have in the previous script. You can just connect something like that and press. If you want a multiple nodes, just press Shift, and then it will combine in one node. So it also works, or just use a merge component and put it something like that. Because this looks really simple, but in most cases, it's really good to find a great curve or surface in the starting point of your design. It will really help your design really make it better in a short time. So don't underestimate in this stage, and try everything you want with the simple curve. You can also use the multiple Bezier curve, like both in the X and Y axis together and X and Z axis together. So you can explore a lot of ways to find some great surface. Even if you don't use this surface for current design, you can just keep it and you can just use it later time. So yeah, now you can just easily, it looks very extreme, but quite interesting, something like that. Okay, so this is the easiest way to make a surface with a loft. And then I'm going to show another loft which combined multiple curves. So I have one arc here and another arc here. So this arc has two different radius. One is 100, one is 50. So this is smaller, and you can change the degree, something like that. So 360 is the full circle, and if you change a smaller one, you can do. Okay, and then I also want to rotate the smaller arc, so I put the rotate component. So you do something like that, you can rotate easily. Okay, now I'm going to divide curve here and also for the smaller one. Okay, make sure it has the same count here and here, so you don't have any problem when you make a 3-point arc. And then I want to make some points and z-axis, something like that. So I also need the same number of points. So you divided 40, so you have 41 points in a point A. Also, it should be the same, 41. And now this is a 41 too. So you just use the same step for the G coordinate. So this is the minimum coordinate of a G in the G axis, and then this is the maximum number. So you can change it from 0, something like that, or make higher number. Okay, and just put it here. So I'm using this point and this one and this one. So I use this all 3 points to make a 3-point arc. So the result is something like that. Because the point in the z-axis is not on the middle of the curves between this point and this one. This is very unexpected. So this is what I like to do. And then just preview. This is the complete surface. It's really interesting. And then you can change some number here, or maybe make smaller openings, or higher, or even higher. Okay, and even you can change the rotation, something like that, or even the same inside. Okay, it looks great. And then let's going to wavy, 1-point wavy surface. Okay, here I made a plane surface, and I'm using a evaluate surface and empty slider. This empty slider makes you to pick the points in your surface, something like that. So you see this cursor followed by your empty slider. Okay, and I also wanna divide this surface into 40 by 40. So now you have all the points. And now I'm going to calculate the distance from all these points to the point you selected in empty slider. To do that, I use the per point. So use all the point, connect all the point in the point node, and then the geometry is what you select the points here. And then based on the distance, I want to set the number for the z coordinate. So the minimum will be 20 and the maximum will be 100, and it will go up to the z-axis. So here, this is the result, and you see this is following the point in empty slider. So the closest point is almost 20, and the furthest will be 100 in z coordinate, like that. Okay, and then I put this point in point component and use the u count here. But I have a +1 here because here this is 1681, but this is 40, means so we need a 41 multiply 41. So this is 1681, what we have here. That's why I add one more here to make a surface. So now preview, yeah, something like that. We have a great surface, which is really easily. And you can just put another empty slider, press shift, something like that, and change the point, something like that. And you can just do that easily. Very strange looking, but yeah, it still works. Okay. And the last one is multiple points in a wavy surface. This time I have a square component, size of 10 by 10 and extent is 40 by 40. And now use area component to have all the center point. And use bounding box to have a boundary to populate the points. Remember, just right click and check union box, so you have only one box for the population. And then side. So I have 7 points on the square here, and then use closest point. So I will find distance from the populated points, to all the center points of the square. And then I will calculate them to minimum 0 to 100 and going up in z-axis, z-coordinate. So what happened is here, something like that. Because I use the reverse, the maximum is here. So the closest is something like around 100, and the furthest is lower than that. Okay, and then going to preview. Now we have a surface, but which is not supernatural smooth. And by the way, here this I didn't put the +1 because this is already 1600 or so 1600, so you don't need to put one more. So just don't need to remember, but always compare the number, so you can put the +1 or -1, something like that. So just remember that. And then when I preview, I will use our rebuild surface to make more smooth surface one. So now I have a UV count and UV degree here in 5. So now I have a much better surface than before. Okay, this is some way I make a surface. So now let's go to the pattern. So there is a 4 way to make a pattern. So let's open the surface pattern. Okay. So number 1, there is a random pattern, which is really simple. Let's just make a rectangle. I'll put the surface to have a surface here, make a surface. And then I use the isotrim and divide domain 2 component to have a subdivision. So here, yeah, now we have a subdivision in a UV count. If you have more number, it has too much, something like that. So for now, I'm using 50. Okay, and I use the jitter, which is the component to shuffle all the data. So here now we have 2500 components, and 0 means no shuffling, and 1 means complete shuffling. So I'm going to show what happened here. So here, multiplication list length 0.4 means I will only select the 40% of the surfaces among these 2500 surfaces. And I put the split list. So list A will be the 40% what I selected. And this one is the other one. Okay. So here, because we didn't shuffle at all, just this is 0. So there is a clear edge here. And you can change the number to list A and B. And then when you start to moving up, this is a 10% shuffling, 20%, 30%, 40%, 50%, something like that. So when you go up to 1, now this is complete shuffled. So if you want to make a really random pattern, just use the 1 default to shuffling completely, or if you want to make something gradually spread out, maybe 0.3 or 0.4 will be great. So yeah, just use jitter to make get this effect. It's really easy and simple way to remember. And then I'm going to make the wood plank pattern. The same as like rectangular surface, and use the isotrim and divide domain again. But this time, I just want to divide the surface in one direction. So I set the V count in 1 and only divide in U count in 100. Looks like great. And then I'm going to divide this each pattern in a random number. So what I'm going to do is use another isotrim and use the cropped because I want to divide all the surfaces one by one individually, and then divide domain 2 again. But still, I also want to divide in one direction too. This time, I keep the U count in 1. Sometimes based on your design, your surface, UV count can be changed. So just try put a 1 and the other number and change it if you don't get the great result. So you can just test it until you have the ideal model. And then I'm going to use the same number. So we have a 100 divided surface here. We need another 100 random number for the division. So use the same number here. And then I'm going to use the minimum 3 division and maximum 12. Just let me do the 1 and 2. And let's see what happened. So you see, sometimes we have 2 surfaces, sometimes we just have 1. When you change this number, 3, 4, 5, 6. So between this number 1 to 6, you will have divisions here. So maybe something like that. Looks much better. Something like that, yeah. Okay, and then we are going to use random reduce again. But now make sure you have a flattened node again, because it should work in the same data under the same data group. So here you can increase the number or decrease the number. Okay, this was the wood plank and height. And let's check out the morph. Actually, this script is from the previous one, the surface, what we have. This surface is great. And then we have another surface. This one is what we have here to make a random pattern. So we have 2 separated surfaces, and I just used the extrude component to have a thickness. For this one is 1, this one is for 2, and I merged them. Okay, so what I'm going to do is use this pattern and morph this pattern to this target surface. Okay, so here. Now we have a surface morph component, and geometry means the pattern what we have here. So this is connected in geometry. And then reference means something like reference boundary. So as always, use the bounding box and right click and check the union box here. And then this is the surface map onto. So this is the target surface, what we want to move here. And then UV domain, just never mind. Normally just work, one will be work, but the W domain is kind of a thickness of your design. So when you turn on, okay. So now this pattern is onto the wavy surface. And then if you bake, we can compare if I put this one. Okay. Let's make it group. Okay, then go to Rhinoceros and view rendered. Looks quite heavy. Yeah, see, this is way thinner than that. This is thicker at 5. So just adjust the W domain to make your ideal thickness here. Okay. And last one is the most simplest one. Use the just Lunchbox. This is a really popular add-on. You can just, use the pre-made pattern division tool. So here you can just have a quad or skewed quad or triangle, whatever. So really easy. You can just download and install, and you see all the patterns you want. This is the easy way. So even here, you see, this is what I showed before in the wood plank here. This just component just solve everything. Like here, something like that. You can just change something like that, and now you have the wood plank. But I still want you to show the basic, the logic, how it works. So it's good to understand how the Grasshopper works, but also it's really good to know something really easiest way, so you can save a lot of time. So it's both of them. Yeah, I hope you to learn. Okay, this is the end of the pattern. And now I'm going to show some good tip when you do the make a script. This is quite a useful script, and I think you used multiple times, and it's really save your time and make your file lightly. So let's open the E utility. Okay. Yeah, the first one is what we already did, because this is a rectangle and isotrim we subdivided in multiple squares and use jitter to shuffle. This is when I used something like when I render something like that, the multiple colors or this kind of voxel things to have multiple colors on the different number of cubes. So now you have a select only 50 list from the total surfaces, and then use another 50 and another 50. So the final result, you will have a 25% and 25 and 25, 25. So this way, you don't need to select and apply a material manually. You can just use this and just bake and apply the material just easily. Super useful. Just I always just copy and paste whenever I render something like that. Okay, and then now we have a second, the select points inside or outside or on edges. What this means is when we have a design, we sometimes want to make a horse, to make a perforated surface. But sometimes when you divide surface, the point is on the edge of the surface. But we don't want to make a hole on the edge. Sometimes it can be a design, but yeah, if you don't want to, you can just do this. So deconstruct VWeb to have a edge of this rectangle and join curves. So now you have a 4 rectangle curves here. And then you can use the point in curve. So the curve is the curve from your surface that you are using. And then point is point which is divide. Will be the center of the circles, maybe the center of the perforation. And then you see when your mouse on the relationship, you said 0 is outside, 1 is coincident, and 2 is inside. So 0, in this case, there's no points outside of the surface. There's no 0, and 1 is coincident. So by now I think 16 points on the edge, and all the other 9s are inside. So the first number, and so the result go to the first number, and I put the second number and a 2. And what happened is, see, now we have only 9 points inside here. 0, there's nothing because no outside points here. But 1, we have points on the edge, and 2 is something like that. And then we can have now we can have a circle. So yeah, 1 and 2, something like that. Shift path means offset each branch. What does it mean is here we have something like that, and then we do shift path, so it's all in the same branch. So it's offset the last one. In this case, you can just do something like that and flatten, and then it also works. So yeah, it's just offset the last branch or just flatten to make all the data in the same branch. Okay. And then let's go to the E3, remove duplicate curve. Now the same, we have an iso trim and divide curve. Okay. So now a subdivision of squares, and using the deconstruct graph to get faces, edges, and vertices. Now, actually, we can do is, I told you we can just connect the edges to curve, something like that. Really easy. This is just few edges here, so it works really well. But sometimes if you have very complex one, but still want to make a pipe structure, it really makes your computer hard. Most time it can be crashed. So this way, we can a little bit make the file lighter. By the way, in pipe, there is a cap option. So 0 is none, 1 is flat, and 2 is round. 2 is the most heaviest option. So if all the curves are connected, you can just delete it. But if you have some problem in the connection part, you can try to 2. But remember, it really makes your computer hard. So just come back. So now you extract all the curves here, and then you can use anything, point on curve and use point 0 or curve middle. And use the curve duplicate. Right click and click the leave one. And then originally we have a 100 points here. Here now we only have a 60. So 40 duplicate curves are gone, points are gone, and then use the same indice here. Now you also have a 100 to 60 curve. Now, now it's much better. It looks like this is sometimes it will help your file works tremendously. It's really helpful. Okay. What about multi-pipe? Multi-pipe. Sorry, would you make it a little bit specific? Yeah, for now, yeah. Let's go another one, but yeah, I will answer later. And the E4 is the popular one. It is the basic when you start the learning Grasshopper. So here we have an ellipse. I'm going to show the really basic way to make a parametric tower base. So move is literally moving up the component, but also it works as a copy when you use the series component. So here, it starts from 0 and step 6. So increase the 6 coordinate in the z-axis, and then 35 count, 35 ellipse here. So it's copied in z-axis, looks good. And then use the scale, use the area component in the center point, and then use the graph mapper, what we did before, to scale down the ellipse. So same way, I use the 35 count, so I need the 34 step to get 35 values for the scale down vector. So I'm using a parabolic here, parabola, and then minimum 0.4 to 1, the original scale. Okay, now you can change, make it smaller or larger, like that. Okay, now looks good, and even you don't need to graph mapper. You can just use the division for the rotation. In this case, this is the total degree I want to rotate, and use the radian. Make sure to use a radian in the step, and then divide the 120 by our count. So here, I turn on the rotation. Okay, so total 100 degree is rotated. So it's from 0 to here. Or you can also use the graph mapper again. Just delete. radian. From 0 to 50, like that, and put this angle here slightly like that. Oh, here, yeah, something like that. Whatever way you preferred. Okay, and then let's go to attractor. So there are many ways to use the attractor. In this case, I'm going to show the curve attractor first. I already put the curve in here. As I said, you can use your own curve. Then have a point. This point is the point on the corner of its squares. And I'm using the curve closest point to get the distance. And then use the sort list to sort all the distance and reorder it from the closest to the furthest. And then I'm going to remap it to 0.1 to 0.5 to use a circle radius. You can just put something like that, but this is too small to see. So I put the multiplication here. So can make down to something like that. Okay. But if you think this is too complex, you can just do the divide the distance and connect directly to the radius. Let's see what happened here. So here, yeah, you can just change the division number and then use directly to the circle. It's really easy. And the principle is always same. And now I want to show the point attractor. So now I also have a populate geometry and use bounding box. Right click, check the union box for the have a single boundary for the population. And then now we have a 3 points. And then now it was the curve closest point, but now it's the closest points. So the cloud means the attractor points here, and this points is meaning the corner of the points of this square. Okay, and then use the same, the division, and we just divided the distance by the number you set. And then let's see. Okay, you can just adjust the number. Okay, something like that. Okay, looks great. So we go over all the script individually, and now I'm going to have a break, and then I'm going to show how I combine this script what we have before. Number 2, this is so simple, it's just a few minutes work. And then going to a little bit complex one, especially 003, 1, and 2. So, okay, this is here in EST is 12:26. So let's meet then 12:27. So yeah, that's a 10-minute break. Okay, now let's go for another one. Let's open the 02-1. Okay. Actually, this part is the easiest one because we already have wrote the previous script. I just want to show how untrimmed surface will work really easy to be applied any kind of design, any kind of pattern. So yeah, here, this is the D1, what we did in the previous script, which is a random pattern with the jitter component. So just easy, something like that. Now it's already applied. Because of this sloped, this untrimmed surface, any kind of pattern which can be applied on untrimmed surface is working. What is untrimmed surface? This is kind of an untrimmed surface. But when we did something like that, this kind of thing is trimmed surface. So this surface is not working in the pattern, what we made here. So it's really good to have an untrimmed surface. So it's for the universality to apply something really easily. Okay, here when you have this something and just use the offset surface, and then to make a thickness, something like that, and have some different distance. So yeah, now you have already something pattern on your surface. So this is a really easy one. And also you can put something like that. So this is D2, which is a wood plank pattern here. So now you have a lobed surface and same thing. Now the plank-like pattern is applied in the Bezier curve loft, and then also it works in a random radius. Okay, something like that. Looks great, and if you wanna make a structure here, just use the curve pipe component and connect the curve, and then use smaller radius to have a realistic structure. This takes time. That's what I meant before. Pipe components are always a very heavy component. Okay, yeah. Now see, we have a structure alongside this wood plank surface. Okay. Now height. And the same thing is the easiest. Just put here, and Launchbox will do everything you need to. All the patterns, it's work. But remember, if you want to have really fluid wave surface, it's better to use the morph, the surface. But in this case, if you use directly connect your surface to the launch box, you have some angles you see here. So if it is okay, if it is your design intent, it's totally fine. But if you wanna follow your pattern to the wavy surface, please just trying to use a morph instead of a lunchbox. Okay, now we are going to do some more, a little bit more complex one than this. So open the 02-2. All right, there is a quite long script. And here, this surface what we have before. You remember we have three, two arcs, and then one G point, and then have a 3-point arc, and then look. Looks really great. And now we are going to have a pattern on this and have some structure, something like that. But before that, I'm going to make this one a little bit interesting. So I'm going to use mirrored Bezier curve, copy and paste here. So what I'm going to do is move these points up in the z-axis and make a hole opening here and here, and then make another loop instead of this one. Okay, so I'll use the arc, the bigger arc, so connect curve in here. So this is divided in 30 pieces, and all the others are same what we did before. So it will work well. And see, these points are moved up in the z-axis. And we have a replaced item. So now we have another set of points instead of the points on the xy axis. Okay, we used the interpolate before, but for now we don't need the curve, we just need the points. So let's leave it like that. Okay, and then and I also want to do the same thing here. So I use the, in this case, the arc, which is rotated. I put this one to divided curve, but make sure this number should be same, 30 to 30. So after that, we can make a 3-point arc again. So this is all same. And like here, you have another opening here. And then replace items. So now you have another set of points which has a potential opening. So you can change the height here if you want, but let's leave it like that. Okay, and then I'm going to connect these big points from the big arcs in point A here to point C. What happened here? Oh, sorry, it was not the interpolate. I need to connect the point to point C. Okay, let's just delete for confusion. Okay, now we have another surface, but seems a little bit strange, right? We have a strange bump here and not something really soft. Okay, let's go back to Grasshopper. And the reason is that this point is just up in the z-axis, this one too. So this is not follow the original lobed surface. So the original one was something like that, which has a softer surface, but these points are off the surface. That's why the new surface was a little bit weird, and I don't like it. So in that case, we can use the surface closest point. So this component will allow you to have a point which is very close to the surface. So let's connect the point we have in here and the surface. We have the lobed surface what we originally have. Okay, now let's preview. You see now these points are attached on the surface, something like that. Now it looks much better. And then copy this one and point here. Okay, looks good. And I'm going to make another arcs repeating and use this point, which is now on the surface, the original surface. Going to point A, and this one to point C. And then use another lobe, like that. And let's hide like that. Okay, now it's much better. It's following the original surface. Okay, now ready to go next step. Okay, much better. And now I have a D2, which was a wood plank. So this is another untrimmed surface. So just connect to the surface instead of using rectangle. So in your preview, something like that, you have a good amount of divisions here. Okay. And also, as always, you can have random radius, or what we did before. Oh, sorry. Before to do the multiplication, need list length to get all the numbers, and then make 0.4 to redux. Okay, looks great. Now we have some basic surface. Just looks great. And then now we are going to make a pipe structure. So we are going to use the E3 here to remove duplicated curves, what we did before, to connect the pipe. So let me disable here. So this first part we don't need. Instead of this part, we are using this part. But the structure, because of this structure, we should not use the random reduce component because it already omits some surfaces. So there is a hole. So instead of this, we can use this one. So connect here and delete it. So this is only for the surface, and this one will be the full structure, pipe structure. Okay, now there is a deconstruct VREP for the to extract faces, edges, and vertices. We need only edges because it's only for the structure. So curve middle to find the middle point and right click. Check the leave one, so delete anything duplicated and just leave 1 point here. And then use same index to reduce the curves. So it was originally 23, 48 curves here. Now we have 1772. Okay. For the better performance, we just remove the cap option and then, okay, so hide all the others. Now we have a pipe structure. Okay, looks great. Okay, and then this is just maybe redundancy, but we can select the random surface for the render. So use the jitter component to complete shuffling, and then select half of them and split it, and then half of them split it again. So now you have all the 25% of each of the surface. And then I put all the offset surface to have a thickness here. So we have all the structure. Let's bake it. Let's bake it. Okay, and structure. That. Okay, let's turn on the render view. Okay, now looks great. We have some simple pavilion with the this script. So we are using very simple script, which I introduced in the earlier. But now we are having some more complex one, and which is kind of becoming interesting. So now I'm going to show another one, which are using these 5 script. So let's go for another one. So open the 02-3. Okay. This will be the really easy one too. Okay, I'm going to hide first. Okay, so now you remember this surface, what we did before. And then what I'm going to do is we also have this one, right? This circle. And now I made some perforated planar surface. So when you want a planar surface, just use a boundary surfaces. But when you have a perforation, connect both the circle and the boundary of the rectangle, and then use the flatten nodes. That allows you to have perforation here. And I use the extrude component and extrude in Z-axis in one unit. So now we have some very light thickness here. So what I'm going to do is morph this perforated surface onto the wavy surface here. So, okay, this is the morph. This is a surface morph. And then, so this is the geometry, what we have in pattern, and have the reference box, which should be union box. Right click and check union box. And then, oh, sorry, let's go with here. So we have the panel here and reference box, bounding box. And then surface should be this one, the target surface here. And then UV domain should be 1, it's okay. And W domain, you can go higher if you wanna make a thicker one. So it's on the preview. Okay, now you have the morph surface, which now the perforation is applied in the wavy surface here. Great. And sometimes this script does not solve all of your designs, so definitely you need to modify or refine it. So that's what I'm going to do. First, let's make some structure here. So I'm going to use isotrim and divide domain to make a subdivision here from this wavy surface, and use the same point because I'm make some unification of the structure on the perforation here. So I subdivided the surface and the result will be looking like that. And then I'm using the E3, always remove duplicate curves. So extract all the edges using the deconstruction BWrap. And then curve point, right click, check lib 1. And then I'm going to delete number 2. And then use pipe structure. It's too thin, maybe we can go for 0.5. Okay, it's good. Sometimes, you know, that's why I'm going to put the number 2 in pipe cap. So if it's your important design, just use number 2 in cap option, like that. But today I don't want to go too much, so just use the best performance based way. Okay, and now I'm going to have another structure from this shell to the ground. So now we are going to use E2, what was the remove points on edge. To do that, I'm going to extract the vertices first. The same way, use the deconstruction BWrap. So here now you have all the vertices, and even the same things, you can remove the duplicate vertices. Just always right click and leave one and connect the vertices. And now the original vertices was 900. And now you only have 256. So it looks good. And go to again, shift path and curve pattern. And extract the edge for the reference. For the edge is something like a square form. And then join curves to use a curve. The edge here. And then it's pointing curve. So now you have something like that. But see, something strange, right? You have something omitted here. Sometimes this is not a planar thing, it happens. But then, when there is a too much height difference, I think it happens for my experience, then just go for 0. Then now you have it. I think it recognized this is the outside of the edge. So now you have 2 curve pattern, 2 set of points. Then just merge. And now you have the 4 set of the points, which is inside of this shell, right? And from this, okay. Now looks great, and I'm going to use this cloud. The reason why I delete the points on the edge, because I'm going to make some very thin column from ground point to this circle, but I don't want to go to structure to the edge of the surface. That's why I remove all the points on the edge. And now we already have the set of points. Now I'm going to make some structure on the ground. So I use the project component. So I project the wavy surface to the ground in an XY plane, and then use the area component to have a center, and use the scale for the 80%. Same reason, don't want start my structure surface. I just make sure just going down. Use population geometry within this scaled down surface. Oh, sorry, I think my connection was lost.
Hey, June.
So
We can hear you. Hello, June?
for this, I have removed points on the edge of the surface ground to the surface. So hello.
Hey, June. Maybe turn off your camera. Or maybe try to rejoin. Hello, I see you.
Oh, sorry for that.
It's all good. What can you do? Internet, you know?
Yeah, I don't know why suddenly. Oh. Mm. Okay.
Okay. Seems we're back in action.
Yeah, hope it good for the rest of the. Yeah. Anyway, can I start again?
Yeah.
Okay. Thank you. Sorry for you guys. So here the last part, I just go over quickly. The reason I delete all the points on the edge here, actually, I don't want to make the structure from the ground to the edge of the surface. That's why I delete. Now that this is what we did. Sometimes the point, if there is a height difference, it doesn't recognize inside of the edge. So I think Rhino has some error for that. So now I have the 0, which is recognized as an outside of the surface, and use merge and use all the points here. Okay, and now I'm going to make the structure. Oh, sorry, we have thing like that. We have pipe and the point for the reference structure. And then now I'm going to make the structure from the ground to this point. So here we have surface and use the project. So make a plane in the XY plane and then use a scale and use a point A or 0.7. So this is the same reason I just don't want to start my structure near the edge of the surface for the aesthetic, for the design intent. So something like that. And now populate geometry for the 6. Then it means I have a 6 starting point of the structure. So, okay, and now I'm going to calculate distance from this structure point to all the points on the shell. So use the closest point and then make a line. So start from the populate geometry points to the closest points on the points in the surface. So use the line component to connect them, and then use the pipe. So yeah, now we have some structure here. You can change the number up here by 4, or here now it's set to 3. But maybe you can make it 2, 3, 4, 5, something like that. You can change it. And okay, now this is a little bit strange. So we'll have some quick structure, make a circle around the points from the starting point of the structure, and then use extrude to make a thickness and make a cap. This is cap component, cap hole. So now we have some base of the structure. Okay, looks good. This is another simple pavilion. And this way can be applied to this multiple points wavy structure what we have before. So let's hide everything and start again. So here I copied again the C3, what we did. And here is the surface, and then I'm going to use the same pattern and morph to the wave surface. So here, what we did is a parent to geometry, reference point from the bounding box, always check union box, and then this surface, go to the surface, target surface here, and UV domain keep 1, and W domain for thickness, let's keep the 3 in here. Okay, then the pattern with hand height. Now we have a perforated surface in a wave pattern. Looks good, and this is all the same script from what we did for the another one, and just copy it, and it should also will work. So here, extract all the edges and leave 1. So it's from 400 to 220. So it's good. And now we have a pipe structure. So let's preview. So now we have a structure behind the surface. Great. And then we'll do the same way, extract all the vertices and just leave 1. And let's see again, 400 points to 121 points. And then I'm going to remove the points on the surface again. Let's check it. Still, it's also have a same problem. Some points are not selected here. So let's go copy with them. And then 1. So 1 means it works well on the edge. And then go to 1, which is recognized for the points are outside of the surface. So use merge again. Okay, now all the points are selected correctly. Okay, now connect the merge to the clouds here. And then I'm going to do the same thing. Project this one to XY plane. And then scale down 80% to make a structure. And set the number of base column. So now it's a 6, you can change. Let's go with 6. And then use the same closest point to find the correct connection point here. So yes, use the line component to connect them, and use the curve type component, a little bit thicker. As always, you can change the count, the number of column here, like that, or keep 3. And let's do the same, just circle for the base, and then extrude them and cap holes. Looks good. So we have a completed pavilion. Let's bake them to see. Let's go with okay, and check in view rendered. Okay, so it's so simple, but we did really easy way just using our script. It's just we just add the structure part, but most of them is from our existing. So we are saving a lot of time, and you can keep adding your library of scripts so for your future design. Okay, now we are going to go another one, the 03-1. So please open the file. Okay. Okay, let's start. So now I have a circle for the starting point, and then have a divided curve. But just circle is a little bit boring, so I'm going to use the V2 mirrored bezier curve to make some modification. So I connect the curve component to here. Then it's divided, and then it's going up. It's a lot, so something like that. So I set a lot of G coordinates 350, and then now we have a set of points here. I think you are so familiar here now. I think it's okay to move. And then I have another circle, which is 3 times more than existing circle, and then divided curve. Remember using the same number for the divided curve here and here, because I'm going to use line component to connect them. Okay, so looks good here. And now hide or other every element. Okay, and now what I'm going to do is rotate this curve, but based on the plane in the middle of this curve. So to do that, let's enable. It's already very interesting. So now extract the number of lists from here. So this is 400, now it's 400, it goes to step. And then let's go to, I just remove the first one because we have 401 values for the angle. So I put the curve index to remove first one because it will go through and meet, the first one will meet the last value. So here we have a rotation. And then because, as I said, the first line should meet the end of the line. So I'm going to use the multiplication of 2 in pi. So it's always the same. So something like that. 1, 2, let's hide. So 4, 5, 6. So yeah, it's always combined here. And let's keep it 4. And now you see the point on curve. We always use the 0.5 to remove the duplicate curve and points, right? But it's actually select the points within these two curves. So you can change the rotation point by changing this value point on curve. So okay, now let's do with some 0.7, something like that, and then make a construction plane. So here all the planes are generated in the middle of the circles and put in z-axis, and you connect to the rotation plane. Okay, looks very interesting for the starting point. And then now I put the B3 sine curve 2 and disconnect all the starting point what we did before, but just use the hour data here. But normally for now, we always use this script to make a direct geometry, but it's also okay to extract just this value. You don't need to use direct curve as always, but I just want some data for the sine curve value, which is remapped to from 0.2 to 0.9. And I'm going to use that for the scale factor here. So here you see the green line, which is a little bit less than the original circle. I just want to add some undulating effect of my surface. So remember, as I told you, you can use the script directly, make your own geometry, or just extract something in part of the script to use to apply another design. Okay, looks good. Good to go. And then I'm going to offset the curve to make a thickness of the structure. So I use the construction plane to make a offset in perpendicular, and use root surface to make a surface between the original curve to offset that curve. So now we have some surfaces that can be worked as a structure. And then this cannot be built, something like that. So I'm going to make another pipe structure which can connect all these surfaces again. So enable this one. So here, the surface, I offset the 2. And I want to make a surface between this, in the middle of the surface. I divided the 2 by 2 and put in the distance here. So now the offset is just a half of the our root surface. And then use the same construction plane and curve middle and z-axis. So now we have a curve in completely middle within the root surface. And then now we have divided curve, or this curve what we generate. So we have points, which is good for making a structure here. But I put the curve index here because I don't want to make a structure from the starting point. So I remove the first points here. And at the same time, I just don't want to make the last point set here. So I use another curve index, but reverse the data. So now I removed also for the first and the last points in this data. So now I'm going to interpolate, but if you put something like that, it's just the line itself. So that's not what we want. So that's why we need the flip matrix and then go to the vertex. Now we have a good structure which is connected vertically, horizontally, and seems great. And just one more thing, in the interpolate there is a periodic node. If it is false, anyway, this is a Boolean toggle. If you don't put something, this is just set to false. And you see there is a gap here. So when you put the true, it's connected, now it's continuous. So it's good to make a pipe structure. Okay. And then let's delete and enable pipe. Let's preview. Okay, maybe we can go 0.2. Okay. Now we have some surface and structure which can go together. And let's go with some modification, further modification of these surfaces. Okay, now I'm going to hide everything again. And then we have isotrim. But now it's not the divided domain, it's like a construction domain here. What this will work is, let me, oh, sorry. I'll copy here. Something like that, and make another rectangle for testing. Okay. I made the 100 by 100 rectangle. And here, actually domain means something like a range. So you can set, if you select some portion of the surface, you can use this one. So now, if you just put one, bake to see the, this is the original rectangle. And if you use isotrim, this means from 0.1, 10% to the 1. So it's 100%. So only 10% is deleted. And you can change something like that. And something like that. Or if you wanna remove in the same proportion from the start and 2, you can just put 1 and minus the same value. 1 minus something, and then you can do the same proportion. You can remove same proportion from the start and the end, something like that. Okay, because the V is always 1, this is the same, but you can do the same thing in V count. Something like that, something like that. So this is good to remove some part of the surface. If you want to use just the middle of the surface, you can just put it like that. So I remove 10% at the starting point and the other 10% at the end point. Okay. And then I'm going to enable everything. And here, now I'm going to use another divide domain to subdivide more from subdivision of 3 to 6 in a random. And then I'm going to use random radius to remove some part, and it makes the model looks more dynamic. So 20% surfaces are gone. Okay, and then now I'm going to make some perforation in each surfaces. And for that, I'm going to use another isotrim. And now you know the construction domain too. So here, now you see, oh, sorry. Now you see there is a small gap because I removed 10% of the starting point and another 10% from here. And then here I set the random value from 30% to 90% in a U direction. Okay, now I extract the curve and make the fillet. You see, we have a small fillet here. It's more realistic. Every model has a fillet or smooth part. Okay, and then use another fillet for the main structure, the outline of the structure here. Okay, then because it's all in the planar surface and the same planar view, so you can use boundary surfaces from both here. So now you have a horse. So this is the outline of the surface what we originally have, and this is the four part inside. So now you connect it both at the same time and use flatten to make a single surfaces. Okay, and then now just enable. This is a offset surface. So now we have thickness. Okay. Okay, it's great. And let's bake them to see how it looks. Okay, rendered. Okay, then just make a surface for the ground. Actually, in real architecture, the construction drawing phase, actually it's really important to think about the relationship between the building and the ground. But for now, this is very schematic design. Just make a simple ground to see how it looks. Okay, it looks great. Opening for potential opening to people can go inside and out, something like that. So, okay. Yeah, looks good. So now we'll go over another one, 03-2. So it will combine 5.6 script for the new design. So let's open 3-2. Okay, let's go with the numbers to point. Okay. Okay, numbers to point means you can just set the number like that, and then there will be a point here. So I set the mask in G, so the point is going up to G axis. But now I'm going to make just a point for the reference points, the center points of the arcs later. So I just make it 0. So the points are duplicated in the center point now. And then I need the 6th point here. Oh, sorry, the 6th step. So we have a 7 points here. And then I'm going to make arc, which is on the XY plane. And then the radius is gradually increased. The start radius is 30 and step is 50. Okay, so it's 330, 80, 130, 180, something like that. I set to radius. And the angle, I'm going to use the random angle. So we have 7 points here. So we need 7 different angles for the rotation. So I'm using a construction domain and put the random. So from minus 180 degree to 0, and the endpoint is from 0 to 180. So this angle generated randomly, so I put it here. So I have a 7 arc randomly generated, and then I offset that arc. Okay. So the green one is offsetted. Because I put the subtraction here, I don't want to offset the curve outside of the next original arc. So I set some limit here. So it should be less than the 50. So it doesn't overlap or go further for that. And then now I use the root surface to make connect the 2 arcs to make a surface here. Okay. And then use isotrim again to subdivide here. Okay. And then what I'm going to do is E5, use the attractor. But it's not really attractor, but I want to sort their distance from the original curve to its center point of this subdivision. So I have an area to get the center point of this subdivision. And then curve closest point to get a distance from the center points to the original curve inside of the surface here. And then use the sort list. So distance is the key. So I'll tell the Grasshopper to sort this surface based on their distance from the center to the curve. And then I'm going to use jitter to shuffle some of them to make some gradual patterns spreading out. Okay. So now what happened here? So when you don't shuffle, it's just close to the first arc and selected the half of them. But when you slightly change it, something like that, it looks a little bit of spreading out effect. And if you want a completely random, you can just put it 1, something like that. Okay, let's use 0.5. This subdivide. And then I'm going to use the scale, use the area of each surface here, and then use 0.95, the factor of the scale down. In render, you can set the UV coordinate to make us to set the correct size of the tire pattern, and use the same bump to make a effect of thickness. But here I just do in a geometry, and actually it looks more architectural and more realistic if you have some gap between this kind of pattern here. So that's why I did scale down all the surfaces here, and then this is the simple extrusion to have a thickness for the landscape pattern. Okay, looks good. And then let's make some outer structure for this landscape. Okay, so this one here, now I have another circle. But I'm using the list item and sort the maximum radius of this arc. Just list item, you can have the minimum number of radius, but because I reverse it, I now get a maximum radius from this. And then addition 50. So this circle should be larger than any circle that we have in our landscape. And then when we have a divided curve, and we'll use the replace members. It's the same as replace item. We used a lot for the Bezier curve and mirror Bezier curve. So, but it's also the same, work the same. So this time I'm going to use this one. And we always use the Bezier curve for now. But for this one, I'm going to use just a random value. So we have 40 divisions, so it's the 40 points. And then I will sort out some points, which is start from 0, and I put 1 because we only need the integer. And then 40 count. And jitter is completely shuffling and just using the seed number 4. Because I want to extract 14 points here. And then, so this is only to gather 14 integers for this index. So here, the green one is 14 points, which I want to moving up in z-axis. So you can change the number if you want a smaller number or larger number. Okay. Because if you just do the list item, you can just have consecutive numbers from 0 to 1, to 1, 2, 3, 4, something like that. But I don't want. I want to select points in randomly. So I use the jitter with the one completely shuffling options. So, and then now you have a list length, because I'll set the 14 random number for the z coordinate. So connect here and use the seed number, and minimum z coordinate is 50 and maximum is 150. And then it's moving up. So now it's moved up in randomly. And then I want to replace these points to the original points, which is on the ground. So yes, now it works. Okay. So now points, which is moved up in the random value. Okay. And then now I'm going to move these points from into the also in the XY axis. So what I'm going to do is deconstruct vector for the all the point from all the points here. I just want to use the G component, which is the G coordinate. So I made a construction point and connect the G coordinate. So you see the points is on the 0.0, but only has a G coordinate. And then use the vector 2pt from this point to this point to this point. What happened is vector display, vector and anchor point here. You see, now all the vectors is toward the outside of this circle, because I wanna this point move this perpendicular direction or inside or out. So this will work well. And then amplitude means you can change the power of the vector. So you can, this case, I'm going to use the random value for the amplitude. So I can use always a different vector for each point. So the minimum will be 30 and the maximum will be 20 for the amplitude. And then let's move these points. Okay. Let's hide. And then use a nerve curve. It's similar to the interpolate to make a connected curves. If you see here, you can turn off the invert. Then you will get this part not connected. So just always invert if you have something like a circular design. Make sure you have a connected one. So now you have a nerve curve which is moved based on the vector, and then this is the original one. So now I'm going to use the loft to make a surface between two curves. Good. And then this is the same script what we did. So yeah, it's always isotrim and divide domain. But now I have a dimensions here because this is an untrimmed surface. You can have a rough dimensions and just divide it in the same number. The reason why I did that, I want something like a proportion, something like a square. So this way it will calculate it automatically. So if you want something like a more square-like panel, this is a good way instead of setting all the numbers manually. Okay. And then now we have a jitter to have a same design language compared based on this landscape. So now we have this VRAP. Okay. So the same design language is spreading out and disappearing to the outside of the landscape. Okay, you can change the number, but seems 0.5 is good enough. And then now the final step, let's always make the pipe structure. So remember, extract the surface here, not here. This is already disappeared some surfaces. So if you need the full surface because you make a structure. So connect to the deconstruct VWrap to extract edges. And then curve middle, right click, leave one. So now it was, wow, it's 40,640. Now it's 20,828. So almost half are gone. And now enable the pipe. Turn on the preview. Seems much better. If you put the cap into I think it really makes a heavy file, so be careful. And now I'm going to bake this one, and then this one. Okay, now go to Rhinoceros, view render. Okay, oh, also we have this landscape here. Okay, now it's completed landscape with a small structure. So yeah, it looks great. So yeah, we keep adding smaller details and using the same script again and again, but we are getting very different kind of dynamic designs for now. Okay, and this is all for combination script, but before going to the Blender, I'm going to show the two simple tricks in Grasshopper. So let's open the 04-1. Okay, actually this one here is what we did at the first time when I started this webinar. I'm going to apply something to this surface. So for now, just hide. And here I make a rectangle and use the box rectangle to make a cube. And then I use the populate 3D and populate geometry. Since the populate 3D, the points are populated within the cubes, and populate geometry is the points are on the cube surface. Slightly different. And I'm going to use the same number for the count. So from here, I have 100 points, random points, and here we have another 100 randomly generated points. Okay, now here, I'm going to make a vector 2pt. So let's check again. And here. Let's check here. So you see, we have the this kind of a line connected from here to here. So we have all the different directional vectors and it's generated. And use the plane normal. So now we have a plane which is perpendicular to this generated vector generated. So what I'm going to do is BREP plane. This will find the intersection of BREP and the plane. So this is cube. It's going this only one, so we don't need wrapped. And this is plane. So let's preview. Okay, now see, actually we have a random crossing pattern here. This is really easy way to get the random crossing, so that's why I want to show you. Sometimes, yeah, you know, this, you want to make a pipe in these curves, but yeah, always be careful. Just start with the smaller number, so use the smaller number of the counts population, and then try increase gradually to see your computer can work in viewer. Okay, and then so now I'm going to apply this random crossing pattern to here. So to do that, just use the solid union and then use the bounding box. Right-click in union box and then connect here and geometry and VRAP. Oh, sorry. Bounding box should be go here, but in VRAP, we should use the solid union. Okay, let's hide to see. Something like sometimes it's red, but it's okay because not all planes can be intersected with this pattern. So let's increase the number of a vector to 300. You see now the higher number makes your model more legible. So yeah, don't worry about the red flag, but still you can apply this random crossing pattern to any of your solids. So just try using this one in the later time. It's really quick trick. And then I'm going to go the last one for the grasshopper. Okay, so now I already set the one VRAP, which is triangular. And I want to show how to make a perforation in this surface. So use this construction VRAP to have a base and edges to extract base, edge, and vertices. And then the use list item. If you really zoom in, you can find the plus, so you can plus here or minus to delete the nodes. So maybe you have just one or two, so just plus to have one more here. Because of this triangle, now you can just connect 1 and 2, 3 to make a 4-point surface. Okay, now it's the same script what we did a lot of times to make a perforation. Here, so the curve is from the surface, and then number 2 to find the interior points. And then use the circle CNR, which is the center point, what we found just within the surface inside here. And then normal, we use the ace planar, so either find your correct normal on this surface and the radius here. So what happened here is now you have a perforate. The reason why I show you, because if you don't do that, just edge, sorry. If you just connect the face to here, you see you have some strange points alongside on the edge. This is not what we want to do. That's why we have extract the vertices and make another 4.3 or 4-point surface to avoid these errors. So something like that. Now we have a correct points what we have. And also this applies same in the quad. So here I already set the quads here. And use this construct VRAP to have 4 corners. Then now we have a divide surface. Then use the same circle CNR, and the result will be the same. Good perforation. Okay, let's check the face again here. Something like that. You see another error. This is better than the triangular one, but still it's not the perfect way. So do something like that. This way you will have a way better surface when you design something, especially to make a perforation in a triangle or quad surface. Okay, now I completed the grasshopper part. And then now let's have a 10-minute break, and I will go over the Blender part or the geometry node, and then how to make material and how to use the cycle render. Okay, so let's have some break. Okay, let's go for the Blender 3D. So for now, you can open the file animation here. You download it, but I'll go over from the starting point. So when you open the Blender, here is always the menu on the top here, and then it is sidebar, and here you can go to transform orientation. I'm not go over with the modeling in the Blender model side, but just let's see some quickly. So you can change all the visibility of the model here, and also the object gizmo, check here, and the viewport overlays. You can turn on the wireframe or something like that, and there is a viewport mode, X-ray or wireframe, shading, preview, render, like that, and you can see all of the properties here. Click like here, you can change anything you want. Here, there is all the render setting and property of the model and modifier, material, something like that. So when you render with the Grasshopper file, in Grasshopper, you can export the file like OBJ or STL. I think that should be great. So just import that file here, and you can use for the render model. And just use a zoom or use a wheel for the zoom, and shift wheel click and for the pen, and just click the wheel is the orbit that, and select the item and press X to delete, and just delete, X, delete, something like that. If you add something, Shift A, and then you can find something plain or Shift A, cube, something like that. And then Shift D is duplicating. D, Shift D, Shift D. And then press A to select all, and then just click anywhere to deselect. And then click the item and press G. It is a move. Also here, you can press this one and use gizmo to move it. Or press G, and X means it's just only move in the x-axis. Or GY, move in the y-axis, and GZ is in the z-axis. Same way, there is a rotation here. You can do something like that, or rotate something randomly, or RZ, so rotate only in z-axis. Okay, and scale is the press S is scale up and down, or SX is only scaling in x-axis, or SY, something like that. Okay, and just press the tab is edit menu. I'm not going to go over this, but just this is always use object mode and edit mode. Edit mode means you can edit this specific surface here, or you can also go to here, edit mode or object mode here. And then press T to show and hide toolbar, or press or click this arrow here, or press N to hide sidebar here. Okay, And as I told you, there is a viewport setting, top right in the interface. And press 7 to go to top view. And Control 7, now it's the bottom. And then press 5 to make orthographic, and press 5 again to perspective. And then press 1 to front. Control 1 is back. 3, this is all plain, so there's nothing happened. But you can see here, left orthographic, C, number 3, right orthographic. On Google, you can just type like Blender hotkey, something like that. You can have tremendous amount of PDF, something like that you can download. So it's a good way to learn the Blender. And then Shift A, you can add camera here. And when we have some good view, we can press Control Alt and number pad 0. And now camera is aligned to here. So here you can just select the camera and press, click the move, and you can move something like that. I'll go over this when we do the render setting. And then just one more thing, Control Alt Q. We'll go to quad view, and Control Q again is come back to the single. Okay, I'm going to delete everything for now. And then I'm going to show something in geometry node. Before that, just go to Edit, Preference, and type the node Wrangler. And see, I already enabled. Just please check and save that. This is really helpful add-on. Whenever you download add-ons, you can just install here. There are a lot of useful things in the Blender market, and there are so many good people are selling their products. So sometimes you can definitely good to check it out. So for today, just we need a node wrangler. So please check it. Okay. And then I'm going to go to geometry node here. Click here and just resize a little bit. And then here, just Shift A, plane. Just make whatever you want and just click and click new. Okay. So group output is something like a preview in Grasshopper. And now it's the same. If your cursor is here and Shift A means you're making something in a modeling space. But if your cursor is inside the geometry node and Shift A is same, and then make something here. So you can just go over all the component here, or just insert Shift A and type grid. So compared Grasshopper, you need to manually connect all the nodes, but in geometry node, you can just click it. It automatically connected. So it's very convenient way. Okay, so you can change the size here, make a vertex, but you cannot see. So for the convenience, I'll turn on the wireframe here. So now you can see. Okay, for now, I'm going to set it for 10 and 8 and 8. Okay, now we have a grid. So, and then Shift A is set position. Set position means I want to move this surface in XYZ axis. To do that, but this time I'm only going to move in a Z axis. also use combine X, Y, Z. And here. Okay. And then there is a math component here. So you can select any kind of function here, add, subtract, multiply, divide, multiply, add, minimum, maximum, like that. So for now, I'm going to set it to multiply the value to Z. Okay. And if you change the something like that, now it's moving to Z-axis. Great. But it's too simple for me. So now what I'm going to do is add noise texture. This seems like something like a material in render, but it also works in a geometry. So vector in here, you see, now it has some noise and move up and down. So 3D or 4D, both of them are working well. But I turn off the normalize outputs to 0 to 1 range, so I don't want it. So I unchecked. The good point of 4D, there is a W point. It's something like a seed number. We can use this to make a really easy animation. So for now, just click here and scale 10, detail 15, like that, or parallel noise to 0. Okay, and then now we'll have make some animation. Well, before to do that, this is too sharp, so I'm going to subdivision surface. Okay, there is a something like a fillet here. So go to here and check keep corners. So now you have a clear corner here. And then increase the level to make more smoother one. Okay, looks good. For now, I'm going to turn up the wireframe again. Maybe, yeah, level 4 should be fine. Okay, and then now going to add scene time and add frame to W. And here on the bottom, there is a frame tab. You can see the frame 1 to frame 3, something like that. And we have total 250. You can change it to here and frame. So now just press the space. Now you see that there is something crazy things happening. This is so fast. So what I'm going to do is the same thing, Shift D to copy. So copy here. The space again is same thing, too fast. Let's make it so low number, 0.0. And then start. You see, it's very smooth animation. So the good thing of Blender is really good for good to work with a mesh, and also it's good to make an animation because it's very intuitive and it's very light. Okay, and here now I'm going to make some really quick animation. Let's go make it 0 and see. This is frame 1 and not click, just make your cursor on the value and press I. So it's a keep frame now. So the frame 1, this value is 0. And then 150, go to 150. And then now screen 2. And then type 10 and press I again. So now it's keyframed 10 in the 150. And then 250, go to 0 again and press I to keyframe again. So let's go from 0. So start from 0 to 10 in 150 and 0 again. So anything there is a value in here, you can keyframe. So it's very easy way to make an animation. So it's 10, you can keyframe. Sorry. I here 150, and let's make 20. Keyframe here and 250. Again, I and I. So let's go. And now it's becoming bigger. And like smaller. Okay, this is a sorry. If I explain everything, it's too much for today. So let's move on. So you can just delete keyframe, right click and delete keyframe and go to something beyond 50 and delete keyframe if you don't want. Also, you can change the scale, detail, or everything in keyframe, and even the location of camera and rotation of position of the camera, and even the text size of the texture in the material. So everything is possible. So that is some basic of the Blender, and I will show another example to make something architecture in a Blender geometry node. So it'll be the file named render. You already have it. Okay, I have a same file. Question, how does compare to this? Oh, sorry, I don't use Houdini, so I'm not sure what to say, but I think many people like to use Houdini, but yeah, Houdini and Blender are both are great. I'm not sure Houdini is free. Definitely Blender is free, so that's why I'm using, and its render is so amazing. So yeah, sorry about that too. Yeah, I have no idea of Houdini for now. Okay. So okay, let's make another geometry node model. So make anything and click new. So now I'm going to make UV sphere and just delete the same, just press X to delete. And then let's make a 64 to 32 and 10 meters. Big. Okay, that's good. And then I'm going to delete the, like what we did in Grasshopper, just delete all the half part below the ground level. To do that, Shift A, delete geometry, and then Shift A, math, change it to less than, and combine it. And then you can set the threshold but nothing happened because we need to set the Z coordinate. To do that, add a separate X, Y, Z and connect Z coordinate value. And you need to connect the position here. Like here, this has an attribute. So here there is an attribute of the model. So here with there is an ID index and normal position, right, or something like that. So because we need the height of the Z coordinate, we need a position node here. Okay, now it's working, but it's good to have another method and use subtract and connect here. So this will be 0 and no 0.1. Because when I delete something, there can be a error near the edge. So this means I subtract 0, subtract 0.1. So I want to delete anything below minus 0.1. This will allow you to avoid any errors near the edge. So I'll just put this one. Sometimes it's redundancy, sometimes it's really helpful. So okay, now it's gone below the ground. Looks good. And then I'm going to do this one more time. Just Shift D and click here. And then Shift D again. Copy here. And connect here. Okay, but here I'm going to delete in Y-axis. So connect Y. It looks good. In the file you downloaded, maybe it will be something like that. So when you Control G, it's grouped. So you can click here, you can go inside the group component and this one to go back, or just right click and ungroup, and you will have the views what I have here. Okay. And now I'm going to make some hexagon pattern. Shift A, pure mesh. But nothing happened, right? Just something strange, small part has been gone. But this is not what I want to do. Because I need to triangulate first to have a hexagon. So it looks good. And just turn on wireframe for the understanding. Then if you want to keep the boundaries, just check this. So you will have the origin, you are keeping the original surface here. Okay. And then like a split list in Grasshopper, there is a node for separate geometry here. And then I'm going to use this one again, Shift D here, and Z coordinate here. Because there are so many smaller surfaces on top, I want to remove some of them. So use here. This all have to go on 10. And then let's slightly lower. You see, because this is set to point, there are some strange edges here. So you can change it to face. Now the face are gone. And make it a little bit lower. Maybe 8.7. Yeah, looks good. So delete geometry, really just delete this part. But separate geometry, you can also have an invert part. and then the selection part 2. Okay, now we have some base point, and then what we did a lot in Grasshopper, we can also do the pipe structure here. So what we can do is Shift A, mesh to curve. So now we extracted every curve from this mesh, and then curve to mesh here, and then you can set the profile curve of the pipe here. To do that, Shift A, curve, circle. Okay. Now it's a lot, like maybe 1.4 is too small, 0.5. Now we have a pipe. Okay, you can change the resolution here. Let's keep it like that. Okay, now you already have a pipe. Sometimes this connection part doesn't look good, so you maybe you want to hide something, or for the structurally you want to add some for the stability. To do that, just Shift A, instance on points. So literally we'll put some instance on all points, disconnecting points here. And to have a preview for both this component and this component, you can add join geometry. So here and here. Nothing happened because we didn't set the instance yet. So Shift A, add the sphere here, and connect mesh to instance. And point will be this original hexagon. Okay, now it's also too big, make it smaller, something like that, 0.1, and you can add subdivision. Okay, now we have some good structure to support. Now I'm going to make a surface inside this structure. So here I'm going to use another separate geometry, Shift D, and click, and use this. And then Shift A, use random value here. In here, and click blurry. And then you see there's nothing because it should be connected to here. So have another join geometry selection. And then connect here. So now you have a faces, but only 50% of the original surface. Can change the number, something like that. Okay, let's go. This is 50%. And then now I'm going to make a hole, the perforation inside of this surface. So what I'm going to do is extrude mesh, but we are not going to extrude yet. So make it 0 and check in on individual, uncheck individual. The reason why I use is there is a top and side, so I can extract only top part of this mesh. So I'm going to use another extrude mesh here, and then only select top part and keep this 0. But now we are going to scale down individually, so check individual. And then Shift A, scale element here. And then top part again, the selection. And then you see, now we have a scaled down surface inside the original surface. Okay, but this is quite boring, so we'll have another random value here, then to here. So let's make minimum 0.1 and max to a 0.8, like that. So now these scales are randomly applied. It's good, and then we can do the delete geometry here, and also top part. Then either way, if you want to disconnect, just Command or Control and mouse right click and cut here. So you can do so. You can do, and then change it to face. Okay, now we have a holes for everywhere. And then now we need really to extrude to have a thickness. Okay, so extrude mesh like that. But see, there's a very strange things going on. What happened here? Because first turn off the individual. I'm going to offset in the get together, but something error. So what I'm going to do is merge by distance. What happened is the vertices is not connected well. That's why it has a very strange forms. When you put the cursor on the component, press mute, press M, is mute the component and unmute. So it's preview and unpreview in Grasshopper. So use this to check your individual component. So you can just put this merge by distance habitually. Sometimes not every problem can be solved, but many problems can be solved with this component. Okay, now it's extruded well, and then now we also need the back part, which is the original surface. So now we need another join geometry. Here, now looks good, but it looks good, seems good, but it's not actually, because when you see here, I can turn on the face orientation. This looks red, because the blue means okay, is the normal is all toward the outside of the surface, but red one is not, because it extruded to the outside. So this is the inverse normal. So in this case, Shift A and flip faces here. And then now we have all blue surface, which is great. And now we are good to go. So I'm going to uncheck face orientation. And then it's good to be again for merge by distance to avoid any further errors. Okay, now it looks good. So I'm going to show how I make the material in this case. So here there is a material tab. Just go and make plus, add material slot, and click new. Okay, and then now go to shading here. Now you have the material here, what you made here. Okay, so basically it's all like all other render settings. You can change the colors, but nothing happened in the model because the material is not set. So make another material. So material, that's like a panel and like a steel. Okay, and geometry, I went back to geometry node and Shift A, set material in here, and Shift D, also for here. So here I'm going to set the steel material, and because this is a pipe, I want to apply the stainless steel. And then here I'm going to apply the panel. Okay, and let's go to preview panel and go to shading again. So now this is the steel. So it's a white one. You can change the color to black or something like that. Because this is a steel, I'm going to make metallic all the way up and change the roughness to 0. So now it's kind of a shiny effect here. It looks good. And then I'm going to go another material, which is a panel. Okay. So now, as always, you can change color, but we can play a lot of things in the metallic and roughness or sheen or even emission. So what I'm going to do is add Voronoi texture here. And you just click the Voronoi texture and press Ctrl T. And then now you get these two components automatically because you already do enable the node wrangler here. It's checked. So any kind of texture, you can just press Ctrl T to get the texture coordinate and mapping. So here, just the one thing you need to do is press object to vector. So your mapping will be based on your object automatically. Okay, and then now I'm going to add color ramp here, then put the distance here, color to base color. Okay, you see, now your color is applied in a Voronoi texture. You can go for a 4D and change the Manhattan or Shabby Shab or whatever. Encode key, something like that. But for now, Euclidean. I like this one. And then normalize. Let's go with a kind of big scale to make some fine texture here. So I'm going to, I change the scale vector to 100, detail to 10, like that. And yeah, it looks great. And you can use this color ramp here, something like that. See, you can change it, the amount, what you want. Okay, looks good. And then, but this color is fine, but since it looks too flat, so I'm going to add another noise texture here, and then vector to roughness, and use same vector here. So it's not really shiny because of the color. It's not too obvious, but definitely it will work more realistic. And then I also want to have a thickness like a bump. So I make a bump and connect to normal go to Musgrave texture. Any texture you want, you can just try, play around like that, and go to height. Now see, we have some bump here. So scale can make it higher to make a little bit looks realistic. So if you make it 0, there's nothing happened. And if you make it 1, this is really have good depth here now. Okay, looks great. And then, but it's not all yet. Sometimes if you wanna have multiple shader in one place, you can also do called mix shader here. So this is one shader, and if you add another shader, you can connect here, both of them, and then change the vector. How many to adjust the proportion of the each material. But not just wanna change the percentage. I wanna do in a Voronoi texture. Definitely, I wanna color ramp here, color to here, then color to vector. So basically, we can control the vector by using this color ramp. And now I'm going to make another print material with texture. And as always, click this one and Control T to have a automatic nose. So connect object to vector. And then nothing happened because this is not yet connected. So I also need another shading. So bump, I will add another bump here. So color to height. And normal to, sorry. Normal to normal. And then one black. Okay, and then, yeah, now I have this material shader here. So I drop down all the roughness here. And then here you can change the setting of the brick material, like 12, something like that. Or offset it 0 to 1. So you have something like a square pattern here. It's good. It's really easy to make simple material in the Blender. And then I'm going to mix these two shaders. So one is previous material, and this one is new, and then do something like that. Okay. See, now it's something like mixed. And you can change the proportion, how much you want for shader A and shader B. Something like that. Okay, looks great. And now let's move to the render setting. So here, there is an EV and cycle. EV is really good for animation because this speed is so fast. But today I'm going to show the way how I use cycle render. So change it to cycle here. And if you can, just change it to GPU compute. And then render, there is a max sample size. Actually, 4,000 is really, really big. It takes really long time. So for now, I keep 128. But if you have a lot of details, just make it like 1000 or 500, that should be okay. And then go to film and check transparent. Sometimes I'm going to show the HDRI, and when you use HDRI, there is a background, and sometimes you don't want, most of the times you don't want to have a background. So just click this one, and you will get the clean PNG. Okay, and here there is a resolution, so you can change it here, and if you export the animation, you can change the start and end frame here, and file format, PNG, JPEG, or for the video, MPEG. And here is okay. And here there is a scene setting. There's no camera here, there's nothing. So let's make a camera, Shift A and camera. And then maybe something like that. This is good. So Control Alt 0. Now it's set camera is aligned to the view. And click the arrow here. You can see the view. And check the lock camera to view. And then now you can change your scene and your camera is locked. So you can set your view really easily. Okay. And then if you're done, just uncheck here. And then I make a matte ground quickly. Because we don't set any lighting yet, this looks a little bit strange, but we can definitely do later. So yeah, now we have a camera. And then now you can orbit anywhere and click this one, toggle the camera view, and then you will go to this camera view. And you can add multiple camera, Shift A, camera again. Or you can just G and Z axis to move, G and X. And you can change the active camera here. This 001 is what we made by now. And go to toggle. So it's like that. When you select the camera, you will have a camera data here. So there is a perspective, orthographic. So you can set something like orthographic view. If you change the orthographic scale, you can like have a zoom out effect. And here you can have a rotation in Z-axis. Here, the object panel. And then this something like strange number, you can set it to 0. And you can move slightly the slider to have a final position. Okay, now we have a two camera here. Now we are going to set the lighting. I'll show you the easiest way. Just go to HDRI Haven. Just Googling this one. Everyone, so many people are using this. This is just free. So go here and finding any scene HDRI based on the shadow. So if you want a really strong shadow, use something like that, or just longer one, this one, or something like interior. You can download this one, night setting. So just download and we can just import that in the Blender space. Okay. So now here, click the yellow dot and choose the environment texture and click open. and go to HDRI, whatever you want to open. I downloaded everything here. So now I'm going to use, where is it? Symmetrical garden. Okay. Now it's already really good to see. And so this is the really easiest way to set the lighting instead of having your own lighting. So it's already have a good quality. So definitely download some of them and try it. But the one problem is this is a fixed lighting. You don't know how to rotate it yet. So go to shading. This is the material what you have. I'm going to save for the safety. Okay, and now here there is it's selected as an object. But go to Word, and then you can see the HDRI you set now. So it's a symmetrical garden. So just click, and the same way, just press Ctrl T, and you get another one. Another same texture coordinate and mapping. So now go to rotation and Z-axis. Just change this one. So in this way, you can rotate the lighting in the HDRI. So you don't need to rotate your model every time. Okay, looks good. And then everything is covered, and go to active camera. And it's done. And go to render and render image. You see, it's very slow. If the first setting was 4,000, you know, and then if the resolution is big, if there will be a subdivision of our render sampling. So yeah, you need to find the best number for your condition. Okay, but in this case, there are quite many details in the texture. So if you want to see clearly the texture, definitely should go on like around 500 to 1000. That should be enough. Good. Okay, it's almost done. So yeah, it's done. And just click image and save as, and save this file in your computer. That's all what you need to do. But sometimes you just want to use your own lighting. So I also want to show that. So here, I just want to clear this Word HDRI file. So delete and new. Okay. And yeah, now let's make a lighting for your own light. So Shift A, light, point. Okay, and then you can move it up like that. And go to render preview. Nothing happened because it's too low. Go to lighting data. And then 10,000. Okay. Now it seems it's working. You can also change the color of the lighting here. Some dramatic colors. For now, let's leave it like that. And then if you use the large radius of the lighting, sorry. You see the shadows are softer than before. So if you want a really strong shadow, just leave it like 0 or very low number. If you want a soft lighting, you can increase the radius of the lighting. Okay. And then you can use another one like a sun spots. In case you use spotlighting, there is a yellow dot here. Just click it and you can rotate the lighting. You can set the direction of the lighting here, like that. Okay, also for the area lighting, you can change the size. See, it's so very softer. Okay, so I'm going to use a point light again, a little bit bluish. And it's totally fine to use multiple lighting, something like that. But a little bit light, 5,000 watt, and make something like red one. Something like that. Okay, and make it higher. Like that. Okay, but you know, sometimes you just wanna something to make a more dramatic or cinematic effect. Sometimes here, you know, it's still the word, not the object in a shading panel. The Shift A principal to volume. Just to add this one and click here. Now it's gone, but density is 0. Density is 1.0. So let's change it to 0.1. Too big, 0.1. Something like that. Now there is like a foggy fog in your model. So you can change the color and density. Using 0.5, something like that. So now you will see some grains in your scene. And now you have some great background, even if you have nothing here. So the lighting mixed with the foggy environment here. So yeah, now it has a more cinematic effect. More. Okay. Yes, I think this is all I wanna share for the render. Okay. And now I wanna quickly share to make a random cube. So yeah, let's do one last thing. Okay, delete everything. Go to geometry node, then plane, click new. Okay, now I'm going to use volume cube. So it's like something foggy cube, not some clear geometry. And then use volume to mesh. Okay, good. But now I'm going to set the XYZ size -2 to 2. Okay, and change the resolution to 64. And then what I'm going to do is use smooth grave texture, color wrap. So height will go here and color to density. You see already have some very strange here. You can change the threshold like that. And detail for 18, that. Yes, like that. This is just really randomly generated, but it's really powerful way to make something new. So it also works with other texture like Voronoi. Like that, or something like that. So it's really good to explore some unexpected form of the cubic structure. Yeah, something like that. Let's go with like that. Okay. Then slightly, I wanna slightly make it more volumetric. Okay, looks good. And then let's do what we did before, delete geometry. It's going to be face and mass less than like that. And let's add accumulate there. So we will get the area of each face. So add face area here and mesh island. So in this way, each of the separated faces indicated as a separate index, and then calculate a separate face depending on their surfaces. Because some of them can be really small, like that. And then I don't want to keep that because that will impact our design. So that can be really strange volume. So not many. So let's check it. So like 10, you see? There is some smaller part here, but when I turn on, it's all gone. See, right? So it's really good to arrange your model clean in a clean way. So this is really helpful. And then I'm going to add your mesh, give boundaries just to remove some triangular forms. And then I'm going to use another Lilith geometry, mass. And this time I'm going to use greater than, because here is all blocked. So I want to cut every part slightly to see the inside of the surface. So greater than and separate X, Y, Z, position, here, and now X axis, and here. So here, this part is cut, and I'll do the 1.8. But I also want to do in this part too. So in this case, I'm going to use another one and check in the absolute. So now there is an absolute value. it cut this way and also in the minus way. So looks good. And then I'm going to do all other Y and Z axis too. So Shift D and this time Y. Go to here. And then another one. Shift D, this time Z axis. And then here. Okay, that's good. And then now there are small particles here again. So what I'm going to do is Shift D, like that, here and here. So now smaller parts are gone again. Okay, good. And then what we did previously also, extrude mesh. Individual channel. I'm going to make a hole inside of the surface. So Shift D. And then connect top part to selection. And then scale element. Also only the top part. And then use random value. So minimum for 10%, maximum for 70%. Yeah. Oh, this should be individual. Let's check with the wireframe. So it has some inset here. Okay, and then delete geometry here and top. And change, make sure you have a face selected. Okay, it's good. And now turn off the wireframe. And what we are going to do is merge by distance. So it's all merged together to avoid any error. And then I'm going to really make the thickness. Extrude face. And 0.1, turn off the individual. And then flip faces. Here. And join geometry. Here. So let's check again. Face orientation. If it's not, just this all red. But when you flip the face, now it looks great. Okay. Looks fine. And I'm going to turn off the face orientation. And then use another merge by distance. Okay, looks good. And then last step will be the subdivision surface. Here. Then like two. Subdivision surface always makes your file really heavy, so please be careful too. Okay, now it looks good for really easy way to make unexpected cubes. So try to use another texture here at the first time. You can make tremendous amount of different kind of cubes using this volume cube. Okay, I think that is all for today on my side. So yeah, I hope it is quite helpful for your future design. So yeah, thank you for joining us today. And I really appreciate it. Yeah. If you have any question, maybe. So if there is no question, actually, this is my email. So whenever you have something, just email me, just mention you took the class, and I can, I'm trying to respond as soon as possible if, I have some idea. So, I'm not sure Michael is here. Okay. Yeah, thank you. Thank you for her. I'm not sure Michael. Where is Michael? Let's wait for him. And also, if you have a problem to open the files while I distribute it, sometimes it's too heavy for your computer, just let me know and I can save some lighter version. So don't worry about that. I can definitely resize the file.
Thank you, June. It was awesome.
Thank you, no problem.
Seems everyone is enjoying it. Really cool stuff going on. Let's see. Seems everything's answered. Anything else you want to add?
For now, no. It's
Sure.
5 hours is quite a long time for me.
Yeah.
And
So thank you everyone. Thank you those who stayed during the duration of the live, and we look forward to seeing you hopefully in next webinars. Just a reminder that the recording will be sent after when it processes. So thank you, June.
Thank you, no problem. Thank you for all of you guys. Thank you.
Thank you. See you.